Hi, welcome to Pebbles. So in this video, I will show you how to adjust aggregations using the material controls. The example file on Food for Rhino has everything set up in BASIC for you. So this is the example that I've set up that I'll take you through how to make. Now within the aggregation tile component, there is the minimum distance, overlap distance, and maximum sum inputs that will control the way that tiles of the same type behave with each other. Within the aggregation maker component, the adjacency allowance and seam minimum distance components are further control over the behavior of the tiles, but this time irregardless of their type. So first off, minimum distance is a measure of center to center distance between two tiles of the same type. So for example, if X was set to 1,000, these two tiles would have to be at least 1,000 units apart from each other. Now the overlap distance, maximum sum, and adjacency allowance inputs work together to create clusters or strings of the same material within an aggregation. The overlap distance controls the maximum distance at which the same tile on two different rows overlap. The adjacency allowance controls the number of the same tile that can appear next to each other within a row. The maximum sum component is the total maximum board length of tiles of the same type when they share an edge. So using those three inputs together, again, can help create interesting strings or clusters of materials. The seam minimum distance, which remember appears on the aggregation maker component, that's going to control the minimum distance between vertical seams all across the pattern, so irregardless of the tile type. All right, so let's look at the frequency input here and see how that is affected by different inputs. So right now I have all these 5 tiles set at 1-to-1 frequency. However, when I connect a tile quantity component to the Pebbles output on the aggregation maker, I can see that there is much less of the first and second tile, which is both the orange tiles, being used within the aggregation. So let's use the frequency to try to get number 2 as the most populous tile within the aggregation. We're going to turn this up to number 2. You can see we've increased its number, but it's definitely not the most populous tile yet. And one thing that is definitely affecting why this tile isn't appearing in the same frequency as the length of the tile, or the width of the tile, sorry. You can see here it's 950, and even the first one is 721, and then all these other tiles are much shorter. And so that's definitely going to affect the frequency of tiles appearing. But nonetheless, let's turn this up to number 3. See if we can get this appearing more often. And boom, there we go. It's appearing 121 times, and then the brown one is appearing 115 times. So using that frequency, you can help create more of a color or more of a texture within the aggregation. Now let's do almost the opposite of that and affect its frequency by making the minimum center to center distance with that tile 1,000 units. Now you can see those orange tiles, those dark orange tiles have to stay 1,000 units at least away from each other, and there's appearing much less sparsely within the whole aggregation. We're going to do the same thing to this lighter orange tile. Now let's see what happens. All right, so there's a few white spaces occurring, which means that Pebbles is trying really, really hard to solve the problem that we've set out, but due to the lack of flexibility within the inputs, it can't find solutions to certain parts of the problem. So one thing we can do in a case like this is to try to adjust this random seed to see if it can come up with a better solution. Turn this to seed 55, see what Pebbles can do. And actually came up with a much worse solution here. So the random seeds sometimes can help, but if it's already a pretty difficult problem to solve, then there's also other times too when it's going to find a worse solution. So based upon the amount of white space occurring, I think we're going to have to change other inputs in order for Pebbles to find a solution to the problem that we set out. So one really easy thing we can do is to adjust the maximum sums of all these last three tiles. We're going to turn this to 5,000. Turn this to 6,000. And we're going to turn this to 6,500. And we might want to allow a little bit more overlap between tiles as well. So let's turn this to 400, which is 2/3 of its width. And let's turn this to 300, which is 3/4 of its width. And this one is going to be turned up to 400 as well. Actually, let's just do a 350. All right, so we're definitely at less white space. Maybe the random seed now can help. And there you go. There's a solution to the problem. One of many solutions to the problem. But you can see that there's much more clumping or clustering of these teals and these browns as well occurring. Just one other thing that I didn't get to is the maximum tries. So this is going to essentially affect the maximum number of attempts that Pebbles will take to kind of find a solution to a problem that you set. So if I made a slider here, I made this 500 max. Now instead of 400 times it'll attempt to find a solution, it'll try to do it 500 times. So that's another way you can also try to find a solution to a problem if it's proving difficult, but you want to keep your inputs the same. So one thing I want you to note as well is that as soon as you adjust one input within the aggregation tile component, or even the aggregation maker component, even one that you wouldn't think necessarily is going to affect the pattern, it's going to. So even if I change the name here, for example, from Aztec Orange 2 to Aztec Orange 4, it's going to trigger Pebbles to calculate a different solution. So keep that in mind. If there's ever a pattern that you really love, use this tile storage component to save it. Drag this down, plug it in, then you right click and you click internalize data. And now we're going to completely mess up the pattern here. Let's turn this to 1, which is a solution that Pebbles can't find. But it's also interesting to note with it when it's turned down to 1, on each row you're going to have an alternation of tiles occurring. So you'll never have two tiles on the same row appearing next to each other. So keep that in mind for design purposes. But now if I want to go back to that solution that I found before, I take that Pebbles output from the tile storage component, plug it into the visualizer, and have the exact same one as before. So certain things that you could use this aggregation function for is different types of strip paneling, different types of facades. If you want to try to create a multi-material hardwood floor or something like that, you could definitely do so. One example that I found pretty cool of a firm that has used something similar is this facade by MVRDV. And this is one of their new buildings, but they have a kind of a randomized facade appearance to it. And I actually I read somewhere about kind of the computational design behind this facade. So that's certainly something you could use this aggregation tool for. So I hope you guys found this video useful. Enjoy. Thanks.